video, we're going to take a look at Climate Consultant, and we're going to specifically look at two things that it can do really well. One is Psychrometric Charts, and the other is the sun path diagram. And neither of these are easy to do in Excel, so this is going to be the best way to approach it. Unfortunately, Climate Consultant is very rich in data and very poor in graphics, so it's a little bit hard to look at. With that caveat, though, there's a lot of really great things you can do with it. And so when you open up Climate Consultant, you'll see this a list of features, and it kind of is designed to walk you through it. So press Next, and Next again, and you can start a new project, and you should select the building type that you've got, either residential if it's an apartment, hotel, or house, or small non-residential if it's a larger office building, laboratory, whatever. Even if it's not small non-residential, this is good to use for now. And select your units, metric, and I'm going to open an existing EPW weather file. I guess I'll use Stuttgart again, since I just used that before. This gives you an overview, and this is useful to see if there's anything wrong with the data. If there's garbage letters in here or zeros, then that's a good clue that something bad has gone wrong. But this is all looks good. I'm going to press Next again. And it's going to give you a choice of comfort models to use. We're going to talk more about comfort later in the semester. For now, I'd like everyone to select the ASHRAE Standard 55 and Current Handbook of Fundamentals model. We'll talk more about this later. And then this gives you a summary of what that comfort model is. All these numbers will become more obvious in just a second. So let's keep going here. And press Next. And you're going to get a whole bunch of different graphics. You can skip right through these. Many of these are not very useful, and they are very kind of dumbed down versions of the graphics we've already generated in Excel. If you come up here to charts, you could keep going through all these different charts, but you can also go to charts and skip right to the psychrometric chart, which is the first thing I'd like to show you here. And this will also give you some suggestion of different strategies to use. We're not going to talk about that right now. Now, right now, when this pops up here, it is a hot mess. There's a lot going on, and the graphics are insanely bad. So what I like to do is to turn everything off just to make this a little bit easier to look at. And you turn things off by clicking on it. So you can click off all these strategies. I'm just clicking them off so that there's less nonsense here. And in the lower left-hand side here, you can also click to fit the chart to the data, which I'm going to do like so. And it either extends it or shrinks it to the extent to the data. What you see here are a whole bunch of red dots and some green dots and a whole bunch of red dots. And on the horizontal axis here is the dry bulb temperature. That's how hot it is. And on the vertical axis is the humidity ratio. That's how much moisture is in the air. These curving lines are probably the lines that you're most familiar with. That is the percent humidity or relative humidity, which is the percent of moisture until the air reaches saturation. So at 100%, this line represents saturation. That's when you get condensation or precipitation, rain. And then as you go this way through these curving lines, it gets drier and drier and drier. So this point over here represents a cool but very moist hour of the year. And this point over, actually, if you go straight down here, it's the same temperature but much drier at this point down here. These boxes describe a comfort region, and you can see right here it says comfort zones show summer clothing on the right and winter clothing on the left. So that means if you're wearing, their version of winter clothing is actually a suit. So if you wear a suit, this is the range of outdoor temperatures when you're likely to be comfortable indoors. And if you wear shorts and a t-shirt, which is the summer clothing, this is the range of temperatures and humidities where you're likely to feel comfortable. So altogether, if you are able to change your clothes you can kind of adapt to a larger comfort zone and wear what's comfortable to you. So then we can add on different ways of filtering this environment with the architecture. So for instance, if we use sun shading of the windows, click that on, you can see that 209 hours then become comfortable, or 2.4% of the year. So, and you can see this purple line here refers to the hours that it becomes more comfortable. If I click that off, you can see maybe some hours that are getting more comfortable. Actually, you don't see them because they overlap with what's already comfortable. If it were to change, you would see them change from red to green, but there's no changes from red to green. And in a way, I think this is a little misleading because it's not 209 additional hours that you're able to sort of buy with sun shading. We've already got those 209 hours that are already comfortable. Let's pick a heating strategy so you can see, because obviously a lot of this is just too cold. And so if we go down here to internal heat gains, you can see now that probably 2,182 hours just turned from red to green. I'm going to click it off. You can see these are red, and now I click it on, and they turn green. So if we are able to harness those internal heat loads being people, lights, and equipment, if we can harness those, maybe through insulation would be one way. By insulating the building envelope, we can harness that heat gain and make those hours more comfortable. And so what I'd like you to do is to click these in turn and see which ones make the biggest difference in order to start to understand how you might operate on the building. Now remember, as you do this, that this is a gross generalization about how your building might perform. And really, this software knows nothing about your particular building. It's just saying, for this climate, many buildings will react this way. And what I think of it as a good starting point to get yourself smart. So I can add thermal mass, and you see that these red dots turn to green. So that's a nice way of getting rid of those. There's still a couple red dots up here. High thermal mass and night flush doesn't add anything more. You see, that's the same 100 hours that is. I'd like you to skip over the active strategies. So direct evaporative cooling, two-stage evaporative cooling, these are active strategies that involve energy. So is the fan force ventilation. But natural ventilation is a passive strategy. And you can see that this overlaps also with the high thermal mass. So you could do one or the other, but you don't need to do both, perhaps, though I would question that. Then we'll go down to the heating strategies. So passive solar looks like it overlaps with the internal heat gain. So if I turn off internal heat gain, I can see with passive solar some of these red dots turn to green. Why do you think all of them didn't turn to green? Probably because some of these red dots occur either in overcast sky conditions where it's cloudy, or at night when there's no sun. So passive solar is only going to work obviously when there's sun. If I add high mass to that, I get some more hours, about 200 additional hours. And then that's pretty much all of the passive strategies we've got. So shade, thermal mass, natural ventilation, insulation, and sun. Now I can look at more active strategies. You see all of these red dots down here are going to require some kind of active heating. So right away, if I go down to heating, I can see that obviously if you add enough heat at any point, you're going to get those. But the important thing to know is that it's going to be very difficult to account for those without adding some heating. So probably having some very efficient heating is going to be a very good choice here. Now the cooling, on the other hand, there's very few hours where cooling is necessary. Maybe about we're at 8748 out of 8768. So 20 hours, actually 12 hours are too hot, theoretically. So one choice would be to just be too hot, go swimming or drink an iced tea during those times. Another would be to try evaporative cooling. No, that doesn't seem to do anything. Or two-stage evaporative cooling. That doesn't seem to do anything. We still have the same number of uncomfortable hours. Fan-forced ventilation. That doesn't seem to help. It's not helping these hours. And what's going on is these hours are theoretically too humid to have these other strategies work. And so because it's getting up towards this more higher relative humidity. So the way to deal with this is probably to dehumidify. So if I click on dehumidification, you can see that these are turning to green. I'm almost there. I have 2 more hours left, these 2 hours right there. And the only way I can take care of those is to actually cool with dehumidification. And you see I've now got all comfortable hours. So when you present this, think about what strategies you want to emphasize. I would not, please don't present it like this with all of them clicked and it being a hot mess of colors. Please choose what you think is going to be most effective and then also annotate these after you're done, after you output it. Annotate it in InDesign. In order to output this, go to File, Print, and then you can print to PNG. And this will create a PNG file quite quickly, actually. I'm going to drag this over, and you'll see that this is now a static image of that you can import into InDesign, create a new layer, and annotate over the top what's important about this and what we should pay attention to. If you want to be really fancy, importing into Photoshop and customizing the colors would be a really nice step.